Good noon to everyone. Good noon to everyone. Today discuss about in the mass transfer operation 1 માં ડિસ્કસ કરીશું આપણે મોલેક્યુલર ડિફ્યુઝન માસ some definition છે concentration mass concentration molar concentration mass fraction mole fractions and the subderivation part some velocities and the last is the molar flow rate flux mass flux molar flux okay and the some derivation part and the fixed flow of diffusion આપણે next lecture માં ડિટેલમાં જોઈશું ઓકે શરૂઆત કરીએ આપણે મોલેક્યુલર ડિફ્યુઝનથી તો મોલેક્યુલર ડિફ્યુઝન આપણે ઓલરેડી જોઈ ગયા છે પ્રીવિયસ લેક્ચરમાં ઓકે ધીસ વન વેન ડિફ્યુઝન્સ રિઝલ્ટ ફ્રોમ ધી રેન્ડમ મૂવમેન્ટ અને મોશન દ્વારા થાય એને કહેવાય મોલેક્યુલર ડિફ્યુઝન્સ અને એ ડિફ્યુઝન્સ છે ઇઝ અ when the movement and the motions with the help of the external force એને કહેવાય છે એડી ડિફ્યુઝન્સ ધીસ ઇઝ ધ રોલ ઓફ ડિફ્યુઝન ઇન માસ ટ્રાન્સફર ડિસ્કસ કરી ગયા છે હવે ડિસ્કસ કરીશું આપણે સમ ડેફિનેશન્સ પાર્ટ ઓફ ધ કોન્સન્ટ્રેશન વેલોસિટીઝ અને ફ્લક્સીસ લેટ અસ કન્સિડર ટુ કેમિકલ સ્પેસીસ એ અને બી છે તો એ અને બી આર ધ પ્લેસ ઇન્ટુ ટુ કમ્પાર્ટમેન્ટ્સ that are separated by a impermeable partitions. Now assume that the partitions is suddenly removed so that the species will diffuse into B and the species B will diffuse in A and this will continue at a constantly decreasing rate until the mixtures become everywhere uniform in the concentration of its constitute in a part of the A and B. Simply, the process is one of the molecular diffusions in which the species are diffused in one another as a result of the random motion of molecules and the rate of diffusion is governed by the fixed law. The fixed law આપણે સ્ટેટમેન્ટ નેક્સ્ટ લેક્ચરમાં ડિસ્કસ કરીશું ડિટેલમાં. હવે જોઈએ કે ફિક્સ્ડ લો એન્ડ બિફોર ડીલિંગ વિથ this law we will define the above mentioned term જેમાં આપણે મોલેક્યુલર ડિફ્યુઝન એ ડિફ્યુઝન અને કોન્સન્ટ્રેશન જોયું ઓકે mention above term the combination of such species. We make it clear here that by the word solution we mean a mixtures of species of the same phases is a gas, liquid, in a liquid, etc. Now one phase a gaseous, a liquid or a solid mixtures. Okay, simple discussion part is over. Again repeated this part concentration velocities and fluxes. Let us consider two chemical species A and B are placed in two compartments that are separated by a impermeable partitions. Now assume that B partitions is suddenly removed so that the species will diffuse into B and the species B will diffuse in A and this will be continue at a constantly decreasing rate until the mixtures become everywhere uniform in the concentration of its constituent. Now A and B જોયું આપણે કે સમ પ્રોસેસમાં શું થાય છે તે ઓકે સિમ્પલી ફિક્સ લોના બેસિસ પર જોવાના છે આપણે હવે જોઈએ આપણે કોન્સન્ટ્રેશન કોને કહેવાય ધ વેરિયસ વેઝ ટુ એક્સપ્રેસ ધ કોન્સન્ટ્રેશન ઓફ ધ વેરિયસ સ્પેસીસ in a multi-component system per mixtures. We limit our discussion to mass concentration, molar per concentration, mass fraction and mole fractions. This is the concentration part. Write down these definitions in your notebook. ઓકે સિસ્ટમ પર મિક્સચર જે મલ્ટી કમ્પોનન્ટ છે એના માટે There are various ways to express the concentration and the mass, the various species in a multi-component system for mixture. This is a concentration. Now mass concentration કોને કહીશું? First of all, the discussion part. The mass concentration of species A in a solution is the mass of species A per unit volume of the solution mixture. It is equivalent to the density of A and denoted by the symbol rho A. For a binary mixtures for solution A and B માટે જોઈએ તો rho A plus rho B is equal to the rho, where rho is the mass density of the solution ના basis પર છે. Okay, write down these equations and a definition. Next જોઈશું આપણે molar concentration. The molar concentration કોને કહીશું આપણે? The molar concentration of a species A in a solution in the number of moles of species A per unit volume of the solutions. The Ca is equal to rho A by Ma, where Ma is the molecular weight of component A, and the unit of molar concentration in the SI system is a kilomole per meter cube. Hence, for a binary mixtures of A and B માટે, the total molar concentration of the mixtures is given by C is equal to Ca plus Cb. Write down these whole equations. What is this? The molar concentration of species A in a solution is the molar number of moles of species A per unit volume of the solutions. So Ca is equal to rho A by Ma. So what is Ma? Molecular weight on a component matter. The unit of molar concentration in the SI system is a kilomole per meter cube. Hence, for binary mixtures of A and B matter, the total molar concentration of the mixtures is given by C is equal to Ca plus Cb. Mass fractions. The mass fractions Xa of a species A in a solution may be defined as the ratio of the mass concentration of species A to the mass density of the solution. X dash is equal to rho A by rho. The mole fractions is the mole fractions of species A in a solution may be defined as the ratio of the molar concentration of A, and this equation is Xa is equal to Ca by C. આ બંને ઇક્વેશન આપણને કામ આવશે. ઓકે, મોલાર કોન્સન્ટ્રેશન જોયું, માસ ફ્રેક્શન જોઈએ આપણે કે માસ ફ્રેક્શન શું કહેવાય છે ઓફ સ્પેસીસ A is solution may be defined as the ratio of mass concentration of species A to the mass density. Simply solution, the rho A by rho. In the mass mole fractions, the mole fraction species A solution be defined as the ratio, the molar concentration A and the molar concentration of the solution. For a binary system of A and B matter, we have the x dash plus x dash b is equal to the 1 and xa plus xb is equal to the 1. Simply the ideal gas flow PV is equal to nRT. The ideal gas phase concentration are usually expressed in terms of partial pressure For an ideal gas, A is equal to PAV is equal to NART. So CA is equal to Na by V plus is equal to PA by RT रखा से. The whole equation write down. Now, what is the PA is the partial pressure and the species of A in the mixture Na is the number of moles of A in the mixture. V is the plant molar volume of the mixtures. Okay, this is the terms of this which one mole fraction. Now simply what is the XA in the terms of CA by C is equal to PA by RT by P by RT, and PA by P is equal, this is the simple equations, and where P is the total pressure exerted by the gas mixtures. Also we have the C is equal to CA plus CB is equal to PA by RT plus PB by RT is equal to P by RT. Now velocities, these equations, whole equation write down. In a diffusing mixtures, various chemical species are moving at different velocities, as they maybe have the different mobilities. The bulk velocity of the mixtures would be some sort of an average velocity. Let ui be the velocity of the first species with respect to the stationary coordinate system. Then for mixtures of n species, the total mass average velocity is u is defined by these equations. Okay. Now the rho u is the local rate of mass phases through a unit cross section when it is placed perpendicular to u. For a binary system of A and B components, we can write these equations. Okay. Mass flow rate equations જોઈ લો. Is the quantity of material flow is the mass unit per unit time, kg per second. Okay, molar flow rate જોઈશું આપણે. It is the quantity of material flow in a molar units per unit time kilomole per second. Flux, mass flux, molar flux. Okay, ફિક્સ લો છે, આપણે નેક્સ્ટ લેક્ચરમાં ડિટેલમાં જોઈશું. સિમ્પલી. ઓકે, ઓલ ધ રિવિઝન પાર્ટ ઇઝ પીડીએફ તમને ગ્રુપમાં મોકલીશ, જોઈ લેજો એકવાર કમ્પ્લીટલી રિવિઝન પાર્ટ માટે. ઓકે, તો થેન્ક યુ સો મચ. સિમ્પલી આ ઇક્વેશન્સ યાદ રાખજો, એક્સ ઇઝ ઇક્વલ ટુ સી બાય સી, અને આપણે યુઝ કરીશું.